Good morning. Myself Neelima, faculty in geology. Today I am just going to share a very small topic from breathing and exchange of gases, that is oxygen dissociation curve. Well, students are so much confused like what exactly is this oxygen dissociation curve whenever we used to give certain conditions, whether the curve shift towards left side, right side, away from x-axis, towards the y-axis. So let us resolve all these kind of questions today. Yeah. So what is this oxygen dissociation curve? So coming to this curve, on the x-axis will pose partial pressure of oxygen and on the y-axis will give percentage saturation of oxyhemoglobin. Yeah. So now the thing is like we used to get the curve shape will be sigmoid. First of all, rather than discussing about what will happen if the curve shift towards right side, left side and all, we need to understand why this curve is perfectly sigmoid in shape. Let us do that first. Say for example, in my body, totally my blood contains 100 hemoglobin molecules. We know that each hemoglobin molecule is going to saturate with 4 molecules of oxygen. Well, I guess you all know that the meaning of this saturation is nothing but hemoglobin can bind with 1 molecule of oxygen, 2 molecules, 3 molecules, but the word saturation exactly means what is the maximum capability of the hemoglobin, like with how many maximum molecules of oxygen it can able to bind with. That's what we call it as saturation. Alright. So now the thing is like each hemoglobin molecule can bind with 4 oxygens, right? Yeah. So now if that is the case of 100 hemoglobin molecules, these 100 hemoglobin molecules, in order to saturate them, we need to provide 400 oxygen molecules. Alright. So 100 hemoglobin molecules will saturate with 400 molecules of oxygen. So now if that is the case, always through breathing process, that is through inspiration, I used to inhale so many molecules of oxygen beyond my requirement. Let us say for example, if my body is having 100 hemoglobins, through inhalation or inspiration, I used to take obviously more than 400 molecules of oxygen, that is let us say 1000. This is the reason why children, even though we stop breathing for 1 or 2 minutes, your body can able to balance. Yeah. So say for example, see here, I took partial pressure of oxygen on the x-axis as I said like. So what will happen here? Let us see. If I increase the partial pressure of oxygen, then proportionate to the increase in the partial pressure of oxygen, percentage saturation of hemoglobin is also increasing, because at the beginning, all of a sudden I'm not providing these 400 molecules of oxygen. Say for example, if I provide 100 molecules of oxygen, then how many hemoglobins will be saturated? 25 hemoglobins. है ना? And if I provide 200 oxygen molecules, then obviously 50 hemoglobins are saturated. If I provide 300 oxygens, then how many hemoglobins will be saturated? 75 hemoglobins will be saturated. If I provide 400 oxygen molecules, yes, you are done. All the 100 hemoglobin molecules are now saturated with your oxygen. See, through inspiration, we are not exactly taking only 400 oxygen molecules, but of course beyond that. So that's the reason why this is considered to be the maximum point in this curve, where we are providing 400 oxygen molecules. We are providing 400 oxygen molecules. Because of providing 400 oxygen molecules, entire 100% of hemoglobin is saturated with your oxygen. Beyond which, even though you provide oxygen, now your hemoglobins are not free to combine, because all the hemoglobin molecules are now engaged with your oxygen, or else they are saturated with oxygen. So that's the reason why beyond 400, even though you provide oxygens, but free hemoglobins are not available in the body. That's the reason why this oxygen dissociation curve is in sigmoid shape. Alright. So now, of course, after we came to understand like why it is in sigmoid shape, now we can easily go through what all the conditions at alveoli and tissue. So that we can discuss in another class. Thank you.